There, this is problem 32 of Neetcode 150. Find the duplicate number. Okay, so let's go ahead and read the problem. You are given an array of integer nums containing n plus 1 integer. Each integer in nums is in the range of 1 to n inclusive. Every integer appears exactly once except for one integer which appears two or more times. Okay, so we have to return the integer that appears more than once. Great, so um, the solution to this problem is not really intuitive, so I will go ahead and show you the fast and slow Floyd's algorithm that is commonly used to solve this problem. Um, So let's say that we have first the list. Let's go with an easy one and say we have one, 1, 3, 4, 2, 2, right? 1, 3, 4, 2, 2. So the trick here will be that the value of the number is going to be the index at which this number is going to point. And we know that basically all the numbers are going to be within the range 1 to n inclusively. We know that. So giving this, we are sure that we are never going to reach the index 0 because we cannot have a value 0 after this initial 1. And we know that we're going to have a 1 for sure to start. So this is like our starting point, and we are never going to go back to the starting point. Okay, and next thing they tell us is that we are going to be given an array of length n, and the last value is going to be n. So we cannot have an index like we can have a number 7 here, for example, in this array of length 6, uh, because it will be out of range, right? We could not make this value point to any other number. So um, this way we can use the Floyd's algorithm, and let's just rewrite this as a linked list where each values, basically the values is the index at which it points. Okay, so index 1 or value 1 here is going to point to well, the index of its value, so 1. So if we go to index 1, we have 3. So 3 is going to point to 1 is going to point to 3. Okay, and now 3 has to point to the index 3 in the initial array, so 0, 1, 2, and 3, which is 2. Okay, and 2 here is going to point to the index 2, so 0, 1, 2. So it's going to point to 4. All right, and 4 is going to point to basically the last index, so 0, 1, 2, 3, and 4. So it's going to point to 2 as well, just like this. Okay, and 2 again is going to point to 4. So we have a cycle here. Okay, so let me use the yellow for the fast, and let me use the red for the slow. Okay, so let's say that we have our slow here that moves by 1. After one round it will be here at 3, right, just like this. And our goal, so our fast runner, is gonna have moved by few position. Okay, all right, so let me erase the previous positions. Okay, and then the yellow is gonna move by 1, and again by 2. All right, and now the slow is gonna move by 1 right here. So we know that the two values are now at um, the same position, so they are intersecting. Okay. um, I don't really like this example because uh, they basically meet at the value that is the duplicate, right? So it makes it a little bit harder to visualize it, but this is the first part of the problem. So we initially want to see where the fast and slow pointer meets. So let me use another example to illustrate the another scenario where the initial place of intersection is not necessarily to duplicate itself. So let's go ahead and have have our other array. So it starts with one as always. Then let's say that we have two, then three, then four, and then back to two. Okay. So if we turn this into our linked list, our one is going to point to the index one, so of its value. So this doesn't change. It's the same principle. All right. So it's going to point to two. Two is going to point to the index of its value. So 2, 0, 1, 2 is going to point to 3, right? And 3 is going to point to 0, 1, 2, 3, which has a value 4. Okay. And 4 is going to point to just like this. All right, so let's go ahead and use the same values. So our gold here is going to be, or our yellow is going to be the fast, and the red is going to be the slow. Okay, so let's start like this. And our fast is initially going to be there, right? So I'm thrilling his path. And our slow is going to move by 1. So it's going to be ending up at 2. All right, so this is the first round. Make a picture of it because I'm going to erase the trace. All right, cool. Once we are there after this round, the slow pointer is going to move by 1. So it's going to go here, right? And our fast pointer is going to move by 2, so it will initially go to the 4 and then loop back to the 2. Okay. All right. And after this, so let's erase that. So first, basically our fast pointer is gonna move to 4 and then to 2. So it will now be at yeah, excuse me. It will now be at 2, while our slow pointer will be at 3. So you can see that they won't intersect this time at the value of the duplicate. All right. Um, so, okay. After this round, the fast pointer, which starts at 2, is going to go move by 2 to the right. So it's going to end up at 4. And after this, our fast or slow pointer is going to move to 4 as well. So now they have a point of intersection here. All right. So might not be super intuitive, but at least we know how we can um, how we can reach the initial state of the problem. So it is going to be to first find this point of intersection, and after this, we are basically going to have another slow pointer. So we are going to erase that first slow pointer, and we are going to um, we are gonna take that new slow pointer to the first index, um, and after this, um, well, I mentioned that we are gonna take another slope pointer. But what's going to happen with our two initial pointers is that we are simply going to keep the first slope pointer, or fast pointer is basically going to be removed at this point. So at the 4, we have our initial slope pointer where that slope pointer intersect the fast pointer at 4. And now we're going to have our second fast pointer at these index 0, and both are going to just move until they they intersect each other's. And you can see that they are intersecting each other's at the value of duplicate. So this is the algorithm we have to trust. If you don't internalize the solution right away, it is not a problem, because it is actually not obvious, and this is probably one of the hardest problem conceptually on LeetCode. So no worries, just understand that first we have to find the point of intersection, and after this we take that point of intersection, we create another slope pointer at the index 0, and just run the algorithm until they meet, and that value where they meet is basically gonna be equal to that duplicates. Okay, so let's go ahead and create our slow and our fast pointer. Both are initially going to be equal to 0. All right, and now we want to while. I will create a while true so we can loop, and if basically the slow equals the fast, so if they intersect, I will just break the while loop. So let's go ahead and do this. um, this might not gonna this, well, if we have some edge cases where there are no duplicates, this code is not gonna work, so we are gonna have to make a if statement elsewhere. But for the sake of this problem, I think Neetcode is not providing any edge cases on this problem, so we can just go ahead and try to solve the problem as it is. And okay, so now we have to actually conceptualize what is our slope pointer here. Okay, so our slope pointer initially is the first element. So how do we get that? Well, we want to get that array nums at the index 0, and it is already at the index 0. So our slow is going to be equal to our nums, pardon me, at the index of slow. And C slow is going to be updated to the value at that index slow. So this is how we are basically going to get our linked list where the value is the actual index it is pointing to. And the fast, well, basically, um, so let's conceptualize it. In this case, or initially, our slow pointer is 1, right? So index slow and slow is going to be equal to 0, so it's going to be here. Okay, so our slow is going to be here, and after this our fast basically is going to be equal to the nums at the index of the value of nums at the index fast. Okay, this is a lot of forwarding, but let's say that we initially set fast to 0, and we want to find first what is the value of nums at index 0. It is 1, and now we are basically just going to take the value nums at the index of that value. So at the index 1, so at the index 1, our fast pointer is initially going to be at 2. Okay, and for the second round, basically the slow is going to be equal to 1 here, right? And after the second while loop, our slow is going to be equal to, is going to go to 2, because it's going to be equal to the nums at the index of its current value, and the fast is going to be equal to the basically it's going to be equal to the nums at the index of the value that this is pointing. So 2 is pointing at 0, 1 2 is pointing at 3. Okay, so we want to have the nums at the index 3, 0 1 2 3, so it's going to be 4, right? So it might be a bit hard to conceptualize, but in this problem you see that in the first round the slow is initially at 1. The fast is going to be at 2, um, and it will be moving by 2. Okay, so this is how we get our fast pointer to move by t. All right, so fast is basically going to be equal to nums, where the index will be that value at that of the num at that slow, not slow but faster. Okay. All right. So after this, if the slow is equal to the fast, this is where we want to break, because we have our first intersection point. Okay. So there you go. After this, here comes the second slow pointer. So we are gonna say basically slow 2, and let's set it equal to 0. And again, we want to have a while through loop, so we can only break if we have our condition through. So when we reach that while through loop, we we already have our slow pointer pointing to the previous point of intersection, and after this we just want to keep it moving by 1. So we are going to say basically the exact same thing we did in the first while loop. So slow is equal to nums at its previous index slow. So this way we can actually move through a linked list where each values points to the index that has the index is going to be equal to its value itself, right? So 3 is going to point to index 3, and the value 7 is going to point to index 7, and slow 2 is also going to do the same thing. It's going to move by 1. Whoop. Like this. Okay. And after this, let's go back to our example. Notice that slow and 2, they they represent, well, slow and slow 2 represents the value, right? They don't represent an index. This is why we use a value as the index of num to navigate through the new linked list. So if slow is equal to slow 2, it must mean that they are at a place where the value here in the initial array is the same, and it is the same because it is a duplicate. So at this point in the while loop, we are going to say basically if slow equal slow 2, then we want to return the value. So we either return slow or slow 2 because they're equal. So this is how we do it. So that's the entire algorithm. It is not super obvious, honestly. I recommend you to actually get to know it, or if you don't internalize it, just like review it before an interview, because um, it appeared quite often on, or it has been reported to occur on many Amazon's interviews. So make sure that you know how to solve this. And now let's run a code to prove that it works. And we only wrote a single equal sign. Okay. Excuse me for this. So let's rerun this again. And there you go. So this was problem 42. Find the duplicate numbers. And we solved this with a space complexity of big O of 1, right? We never created extra space. And I'll let you guess the time complexity. So it's a big O of n, of course. So I hope you learned from this video, and I hope to see you in the next one.